here, that's just triggering the UV direction warning window if something goes wrong with it. I mean, there's comments everywhere, so you can just go ahead and read all of these. Okay, here we're building a matrix, so with all the connected vertex of each vertex. So we're going through every single vertex of your actual geo, and you're just like storing these in a matrix, pretty much. The connected vertex. So you go to each vertex. Let's say you go to vertex number 1 and you see, oh, it's connected to vertex number like 6, 7, 8, 9, whatever. So I'm just gonna go to position like 1 of the matrix and then store 6, 7, 8, 9. So it knows like, oh, vertex 1, this is its neighbor. So it requests all of that, put that in a big matrix, so it's easier to access it afterward. There's going to be a lot of like, let's look up some information like that and store it in some matrix. And there's also that like, I'm kind of like storing it all at some point and not storing them like every time it computes. So it just makes things faster. It's just to optimize the whole thing, and then it has to figure out like, oh, now like stuff changed, so it has to rebuild these metrics. So there's a lot of that going on, but it won't, like, if you delete part of the mesh, it won't like figure out, oh, the part of it has been deleted, so now I'm just gonna recompute on what's left of it. You better just delete the node and recreate it for that sort of things. It's more like if when attributes change and when it needs to retrigger these metrics that it does that. Okay. Some more matrix creation going on here. See here, like connected phase. It's just storing some information in these matrix that we're going to use later on. Okay, filling up the matrix with the connected vertex. Here's for the UV direction. So that feature here, it also has like all of these shapes. So it's storing some matrix related to that feature. So just storing gathering some information on the mesh, and so we can use it later on. Okay. Here, getting all the information about their grow, shrink, relax, weights. Okay, now here we're actually going for every point and calculating the tension that's happening. So now, like, you know, like we requested the neighbor. So the idea is that we go to a point, we check the neighbor, and we calculate the distance from the original point to all of the other neighbors, and then we actually stored that value when the mesh was like at its default position. So we know like when it's at default position, let's say the value was like 1, 1, 1, 1, 1, 1, and now we're gonna, as it's moving through time, let's say the thing got all stretched, and now the value is gonna be like, oh, like 2 here, 1 here, 2 here, 1 here. It's gonna take all of these, average them out. So I guess it's like 1.5, the average of like 2, 1, 2, 1. And now it's going to compare it like, oh, by default it was 1, now it's 1.5, so there's like 0.5 tension happening. If it was like still 1, the whole thing, it would be like 0 tension happening. And it can go like -2 if there's compression, so minus 0.5. It would be like, let's say like 0.5, 1, 0.5, 1, so something like that. So we're just calculating the tension here. Again, here open MP, so all that stuff is happening in parallel. Speed things up a lot. Here, like, we have the actual stretch here. So here we use this one through the procedure to just like get the value, put it in there, do the calculation, put it in there. This one is like the actual like current stretch. This one is like the rest stretch. So like when it was in default position, what was the stretch at? Well, it's not actually the stretch, but it's like the actual distance, the average distance to each neighbor. So I just called it like rest stretch. And basically we compare the rest stretch to the actual current stretch. Okay. And the idea is that we go through each vertex of the geometry, and each vertex we go through every neighbor of it, and we average it out, just like I explained. Here, when we found out the tension, we can just smooth it out, so it's not like sharp per point, so it can like bleed a bit through the other points. So let's say here, if we put on the draw color per vertex, if I move this like that, and I crank this maybe like, it can be a bit harsh here and here too. So if you want to smooth that out, you just go here, oh, I'm in the angle base. Let's go to tension base plus smooth. So that helps a lot here. So this is just going through like all the vertex, and kind of like all vertex, it's taking the stretch of the neighbors and kind of averaging out all of the neighbor and taking the average. And as you do that multiple times, it's like here, how many times are you doing this? How many times do you iterate and do that smooth? It's a number here. Okay, here all the angle part, all this part here. I mean, this one is just, it's the whole same idea, but instead of being tension, so distance from one point to the other, it's just being the angle. So let's say the angle started like that, now it became like this, or it became like this. So same old stuff, but with angle instead. Here, just smoothing the angle. Now it's multiplying